Hello students and welcome to Chemistry B. I'm Ms. Slate and today we're going to talk about the colligative properties of solutions. So first off, we should all know that pure water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. But something that you will notice is that once you add salt to water to make a saltwater solution, the boiling point and freezing point both change. The boiling point of a saltwater solution is always higher than the boiling point of pure water, so it's above 100 degrees Celsius. And the freezing point of a saltwater solution is always lower than the freezing point of pure water, so below 0 degrees Celsius. These changes that we notice when we're comparing the properties of a pure solvent to a solution are called colligative properties, because these properties depend on the number of particles of solute that are dissolved in the solution. So the first colligative property we're going to talk about is freezing point depression. So basically, depression meaning going down because the freezing point of a solution is always less than the solvent. So to figure out the freezing point of a solution, you just need to take the freezing point for the solvent and subtract the change in the freezing point. In order to determine the change in freezing point, you're going to take the Kf value, the freezing point constant of the solvent, and multiply it by the molality of the solution. And there's a table of freezing and boiling point constants in your packet. And again, like I said, the little m is molality. So let's look at an example. It says, what is the freezing point of a 1.18 molal solution of sodium chloride in water? Well, as I mentioned before, the freezing point of the solution is going to be equal to the freezing point of the solvent minus the change in freezing point. Well, in this case, our solvent is water, so we know our freezing point is going to be 0 degrees Celsius. So we just have to calculate our change in freezing point. Well, the change in freezing point is going to be equal to the freezing point constant for water, which is 1.86 degrees Celsius per molal, times the molality, which is 1.18 molal in this case. And we find that the change in freezing point is 2.19 degrees Celsius. Well then, to find the freezing point of the solution, we'd just take the freezing point of water, 0 degrees Celsius, minus 2.19 degrees Celsius, which gives us a new freezing point of negative 2.19 degrees Celsius. So fairly simple calculations, as long as you have your freezing point constant table open. And like I said, that table is available in your assignment packet. The other colligative property we're going to talk about is boiling point elevation. Elevation meaning going up, because when you add a solute to a solution, that raises or increases, elevates the boiling point. It's a very similar process to freezing point depression. To figure out the boiling point of the new solution, you're going to take the boiling point of the solvent and add the change in boiling point. Once again, to find the change in boiling point, it's just going to be the boiling point constant times the molality. So let's look at an example. What is the boiling point of a 1.18 molal solution of sodium chloride in water? Well, once again, if we want the freezing point of the solution, that's going to be not freezing point. If we want the boiling point of the solution, that's going to be equal to the boiling point of the solvent, which in this case is water, plus the change in boiling point. Our change in boiling point is equal to the boiling point constant times the molality. Well, the boiling point constant for water is 0.512 degrees Celsius per molal. And they told us our concentration was 1.18 molal. And so we get a change in boiling point of 0.604 degrees Celsius. Well, again, if we want the boiling point of our solution, that's just going to be the boiling point of water, 100 degrees Celsius, plus our change in boiling point, 0.604 degrees Celsius, which gives us a new boiling point of 100.604 degrees Celsius. So, determining the new boiling point or the new freezing point is not very complicated. And also, like we talked about with many of our other equations in this unit, both of the equations for boiling point elevation and freezing point depression will be given to you on a formula sheet for the quiz.